So with that, we start our August the 8th, I think. No, August the 4th Kubernetes community meeting. And we have a lovely, full, exciting agenda ahead of us. And our first topic is going to be a demo from Aaron Levy at CoreOS about Bootkube and self-hosted Kubernetes. So Aaron, can you introduce yourself?
Yeah, so my name is Aaron Levy. I'm a software engineer at CoreOS. And yeah, I just wanted to talk a little bit about some of the stuff that I've been working on here, mostly relating to self-hosted Kubernetes. And then a little bit about a tool called Bootkube, which kind of helps you launch self-hosted clusters. Let's see, trying to share my screen. Can you guys see this presentation?
Yes, we can, Aaron.
Okay, cool. So I'm just going to quickly go over some of the background just to give an idea of what self-hosted actually is. So just in general, what it kind of means is that Kubernetes is managing its own core components. Say self-hosted, that's what we're talking about. What this actually means is that all of the cluster components, things like API server, scheduler, controller manager, they're actually managed as higher level API objects. So things like daemon sets or deployments, any of the actual cluster components, essentially we want to model as Kubernetes objects. And the end goal of this is that our host requirements end up essentially being that you have a kubelet and a container runtime, and then everything else is kind of stacked on top of that. So just kind of a general look at what a self-hosted cluster might actually look like. The way that we've been deploying it today, if you were to take a look at the deployments in your cluster, you might see something like controller manager, scheduler, DNS add-on. And if you were to look at the daemon sets, you would have components like kubelet, kube proxy, kube API server. And in this case, this is showing a 3-node cluster where there's, for the daemon sets for the kubelet and the kube proxy, there are no node selectors. We want these to be running on all nodes in our cluster, and so we have 3 copies of those. The API server, we just want running only on nodes that we've set a node selector of master equals true. So we just have one of those there. So what are the reasons that we might want to self-host Kubernetes? And a big part of this is that we get API-driven updates. And so that might look like something, I want to change flags, or I want to change the version of my scheduler, for example. Essentially, that's just using normal Kubernetes tools to do this upgrade by saying, kube control apply these updates to the cluster. And in the background, what's happening, because the scheduler is an actual deployment object, what's happening is that the inside of Kubernetes, the deployment controller is managing the rolling update of that component. So it's killing an old pod and then replacing it with a new and going across your cluster and managing that upgrade process for you. Another reason is you get to use your typical cluster introspection tools for debugging and such that are already built into Kubernetes to inspect the actual Kubernetes components themselves. Or maybe something like secret rotation that can be a little bit difficult otherwise, where let's say that you wanted to change the TLS assets for your API server. What that might look like in a self-hosted cluster is that you create a new secret that contains your new assets, and then you create it, you push it into the API, and then you can then update your API server manifest to reference that new secret. And then behind the scenes, anytime an API server pod is launched, that secret gets deployed with it, and you've rotated your assets. A really big reason that we're excited about self-hosting Kubernetes is that it makes upgrading Kubernetes much easier. So if you were to look at what it might be like to upgrade a self-hosted cluster, essentially we should be able to get it down to more or less these kind of 5 commands. Update the control plane first, and then update kubelets and kube proxies after that. And we're not quite to this point yet. There's some more nuance here. But we're not that far away. So one of the things I wanted to do was demo upgrading a self-hosted Kubernetes cluster, but just doing it by hand manually. Let's see. So I have a 2-node self-hosted cluster running right now. I've already started it. And so I'm going to go through and just do everything of a cluster upgrade just using kube control and only kube control. Hold on, part of this meeting stuff is in the way. All right. So if we take a look at those things I just talked about. So here's our deployments controller, manager, scheduler, DNS. If we take a look at the daemon sets, the API server, the proxy, and the kubelet. So if we want to update the cluster, we want to do the control plane first. We want to do the API server first. So let's just take a look at what the version we're running right now. So my local kube control binary is 134, but my API server itself is actually running 130. This extra at the end is CoreOS build metadata. The API server itself is a 130 API. So we want to update that to 134. So when I said that, we're not quite there yet on, those super simple upgrades, one of those pieces is that daemon sets don't support rolling updates. So we're going to do the rolling update ourselves. So that looks like we're going to edit the actual manifest. And so what I'm doing here is, this is just the image field of our pod spec inside of the daemon set. To tick it up and say, well, we want the API server to actually be running 134 instead. Now, when I save this, nothing's actually going to happen because there's no rolling update mechanism of daemon sets. The daemon set controller will replace this pod if it doesn't exist, but it's not going to roll it for us. So we take a look at the pods. We can see this is the API server that's currently running. It's been running for 26 minutes. So what we need to do is we need to kick this ourselves. So, all right, now I'm not going to be able to do anything for a second because we just killed the API server. So we need to wait until that comes back up. So in the interim, I just want to talk a little bit about Bootkube, because everything we're doing here is just interacting with Kubernetes, just using vanilla Kubernetes tools. But the way that we got there is using Bootkube, which is a tool that is meant to get you from zero to a self-hosted cluster and then get out of the way, and you don't use it after that point. It's for the initial node bootstrap, just on a single node. And essentially what it is it's acting as a temporary control plane just long enough that it can be replaced by a self-hosted control plane, because we kind of start in this chicken and egg situation where you need an API server to inject manifests, but there is no API server running. So how do you rectify that? So Bootkube itself is essentially a single binary that's running an API server, a scheduler, and a controller manager. And then it runs long enough, you can inject manifests into it. It watches and waits until it sees that a replacement API server, controller manager, and scheduler is running, and then it just dies and you don't need it anymore. Not going to be able to go into a whole lot of detail about it, but take a look at the GitHub for it, documentation, builds, reference implementation, that kind of thing. Launch local clusters and kick the tires. Or we have a Google Doc that actually goes into a lot more detail about the design of each of the self-hosted components and how it all works together. So you can take a look at that as well. Let's check on the API server. Should be back. Okay. So we can see that suffix has changed. The API server got rolled. It's only 33 seconds old. So if we were to check the version now, it hasn't updated itself yet, 33 seconds. We got to wait because it has to update the status. Okay. Oh, no. Okay, there we go. So now version 134, it just ticked up its status. So now we need to do the rest of the so deployments are a little bit more interesting because I can just do the scheduler. So what happens when I save this, in the background, what's happening is the deployment controller is going to see that it's been modified, and then it's going to do a rolling update of those components for me. And so it may even do it fast enough that I don't even see it. Get the pods. Okay, we can see that scheduler is now container creating because the deployment controller is seeing, okay, well now the manifest doesn't match what the actual deployment is, so we need to roll those pods. So we've just done our scheduler. Now we can do the same with the controller manager. All right, so that's been updated, 3 seconds old, pretty quick. So now our control plane is updated. We have a 134 control plane. Now we want to do the nodes themselves. So again, both the proxy and the kubelet are daemon sets, so we have to do our manual kind of rolling update. So the first thing I want to do is edit the actual daemon set. Let's do the proxy first. And then we're going to delete each of the pods individually. So that one's already updated, 2 seconds old. Do this one. Okay, that one's been updated. Now let's do the kubelet. First, oh, actually, before I update the kubelet, let's take a look at, like, verify the version they're actually running. So if we get nodes, and I'll put this as YAML, we can see in the node object, the kubelet is updating the status of the node with the versions of the proxy and the kubelet locally on it. So we can see this node in particular is running 130. So we've updated the daemon set, but we still need to kick those pods to see that update roll over. Do this one first. And these can take us a little bit longer just because to actually terminate. All right, so now I think, yeah, so 20 seconds old. Let's do this one.
So Aaron, can you wrap up in about 2 minutes and then we can take a couple questions?
Yep. We'll see if, so this is now, we should have a fully upgraded cluster now. So we've just gone from 130 to 134 on the control plane and as well on all of the nodes. Let's see if in a minute I can make this HA as well. So if we were to say, so scale up our controller manager, scale up our scheduler, and then let's see, we want to add another master node so the API server gets deployed there. And what we should see now is that we have 2 API servers running, 2 controller managers, and 2 schedulers. So within, I don't know, a minute, we were able to expand our cluster and essentially make it HA. So this is kind of like the reason that I'm pretty excited about just the self-hosted path in general, is because Kubernetes is really good at managing pieces of software. It's really good at doing these kinds of things. So if you use that power to actually manage itself, it makes things like upgrading your cluster, managing the lifecycle of it really, really easy. Oops. So yeah, that's my demo for today.
Sweet, thank you.
Sure.
Do we have any questions around this? We've got time for 1 or 2, and then we've got a full agenda. So, and Brandon, there's a discussion on SIG cluster lifecycle as well that is going on. Giovanni asks, is etcd managed in the same way, and is this all going to land in 1.4?
So etcd is not right now, but that's in the plans. There's 2 outstanding pieces we still want to in the short term start self-hosting, the pod networking tools, and then also etcd as well. But yeah, etcd right now is still managed outside of the cluster, but we would like to be able to manage all components in this way. And then as far as 134, I mean, most of this is just vanilla Kubernetes right now. So the only things that we're really doing are using Bootkube, which is a means to an ends, which is get past that chicken and egg situation, and then after that, you just have a self-hosted cluster and you're just using vanilla Kubernetes. But that essentially doesn't, like, there's other options that we could have. And some of this has been discussed, like kubelet side APIs and stuff, where Bootkube isn't really necessary at that point. It's just now we're just operating on self-hosted clusters past that point.
So there's a little bit of discussion about, is this all clusters all the way down, or all turtles all the way down, cluster upon cluster upon cluster?
So yeah, this is, if you were to think about it as one actual flat cluster, it's not necessarily clusters inside of clusters. The turtle at the bottom is the kubelet. And in our case, we are self-hosting the kubelet as well, as you could see there where I was rolling the kubelet objects, but underneath them, the turtle at the very bottom is a kubelet that runs on the host long enough to be replaced by a self-hosted kubelet. And in that design doc I mentioned, and I can link it as well in the doc, we go into how that actually works. But again, it's vanilla Kubernetes. It essentially coordinates around a lock file. And so this is just, how you can deploy on Kubernetes today already.
And this work is happening inside the SIG cluster lifecycle. That's where much of the discussion is happening. Fantastic. Yeah. So 2 quick questions, I hope. What happens if you accidentally bork the API image reference in the spec when you're upgrading? Bad things?
So, that's part of the reason that you want to have rolling updates of these components, is that, so if you do screw it up, that you're going to roll it back. You're not going to, if you're being a safe operator, you're not going to go out and blow away every API server you have at the same time with bad images. So I actually think that this gives you a lot of power in that regard, where, you're going to do these kind of canary deployments and do it slowly and be like, okay, well, that went out. And then the next step of this is that if I can do this manually by hand without much difficulty, it makes automating this process not that difficult either, where a controller loop could sit there and do the same thing and say, well, I'm going to bring up an API server that's new. Did it come up? Is it functioning properly? Okay, I'm going to go on to the next one. Once the API server is done, then I can go on to the kubelets and I can roll each node. Are those nodes coming back up safely? If they're not, stop the update process. Mm-hmm. So I think that this lends to being like a pretty safe perspective from an operator, because Kubernetes is really good at these types of things.
Awesome. And Ilya, I think that answered your question, but if not, I'm going to send you out to SIG Lifecycle in order to ask more questions, because we're going to move on to the next item on our agenda. Thank you so much, Aaron.
Cool. Thank you, guys.
Yeah. All right. Oh, claps. Yay, from Joe. All right. So up next is Prashant talking about PetSet. And Prashant is sitting next to me, so I'm going to point the camera at him, and he is going to get to talk.
Cool. Hey, what's up?
Hey, you're good.
Okay. What's up, guys? So I just thought I'd give a quick update to people who are interested in participating in PetSet development on the whole. I don't have slides or a demo. I'm just going to talk, so you get to look at my face.
And ask questions.
If you want. Okay, so I'm going to try and keep this brief, because the breadth and scope of this particular topic has a way of filling up the available time. But to start off with where we are today, we have an alpha resource called PetSet. It's a working title, and there have been objections to the name. And it has a bunch of properties that are layered on top of replica sets, so to speak, that enable you to deploy and manage clustered applications. We picked a couple of applications that represent different classes of databases, such as active-active, for which we picked MySQL Galera, Quorum, for which we picked Zookeeper, master-slave, for which we picked Redis, and we also have decentralized Quorum, Cassandra, in the works. And we sort of isolated some of the properties we need to deploy these automatically and manage them as they scale, and essentially pushed out an alpha resource. And so where we are today is we have this alpha resource that provides a stable identity to your pods, startup and teardown ordering, an ordinal index, and certain other nice things that help you protect your cluster. And we have end-to-end tests for the databases I just mentioned that are essentially running back-to-back and prove that we can more or less do the basic things you would expect with the database. The end-to-end test is pretty basic sanity check. We just write some keys, restart the entire cluster, read the keys, do some more checks like that. So all this is pretty sort of basic. It just proves that we can in fact deploy and manage stateful applications for the happy path on Kubernetes. There's still quite a bit of work to be done, but that's where we're at. Where we're going from now is, there's a lot of work, like I said, to be done. There are major buckets that you can classify the work in. The first big bucket is probably there are some operational challenges and user interface things that we know we need to do. And the work here is just implementing the things in kubectl and writing tests that make it stable. Examples of such things are rolling update and scale up and down. There have actually been reports that quickly scaling a PetSet up and down causes some weird issues, which, I'm totally willing to believe because I didn't design it to be quickly scaled up and down. At the very least, it'll be much, much slower than a replica set. So if you try to, create 100 replicas and then come down to 10 or something, there are probably going to be issues. But these are more operational. Another thing that's probably in this bucket is recycle policy on dynamically provisioned volumes, which we currently don't have, at least those created for PetSet, right? So these are just things that, would be nice, would make using PetSet easier. We know we need to do. Obviously, needs to be consistent with the rest of the kubectl verbs. And the work here is just, we need to implement it. The second big bucket is networking. There are a bunch of open questions in networking, and a lot of us kind of know how to solve them. I'm punting on committing to anything right now. The open questions are along the lines of, we need static IPs for pets, we need public IPs for pets, or public identities in some way. Certain pets absolutely cannot tolerate DNS apparently, because they don't respect TTL, and even if you set a short TTL, they just ignore it. So by and large, I found that a lot of the databases have evolved to accepting host names, and PetSet today gives you host names, and the ones that I've prototyped work out well for the failure modes that I've prototyped again. It might totally be the case that we need IPs to successfully deploy all databases to production. And this is kind of on the table right now, and I know how to solve it in some ways. And if we absolutely needed it right now, we could do a service per pod, but there are some limitations in doing that as well. But that's where we're at with IPs. And with external IPs or external DNS names, or some way to access each pet externally, there are a couple of ideas that have been proposed. Probably the simplest and most basic idea that you can do right now is set up HA proxy and pass a cookie header saying, I want to talk to pet 0, I want to talk to pet 1, and so on, and HA proxy will route you. Probably more complicated version is, create a service per pet yourself and then expose that service through node port or type load balancer. If we wanted to offload some of this work to PetSet, we could by, PetSet already today requires a governing service, which is responsible for the network identity of all the pets. So we could make that, and today that governing service is a headless service. We could make that governing service a different type, such as type node port. And there are some challenges that we need to figure out, such as allocating a node port per endpoint of the pet. But these will get worked out in time. And what I'm really looking for is hard use cases that say we must have IP, we can't tolerate DNS names, and prototypes of the same that are essentially, you today have IP and you could, just wave your hands and say, assume the IP doesn't change and build the prototype and then say, okay, now you need to give me like a stable IP so I can deploy it to production. That's networking. So the third bucket is storage. And in my mind, this is probably the most interesting right now. There's a gap today in PetSet that I believe like a couple of people have submitted very good prototypes, most notably Cockroach and etcd. I think Jan from Red Hat supported, just recently submitted one for etcd. And the thing that stood out to me was that storage prevented them from actually deploying something that we would call more or less production ready, right? We don't have a local storage option today. We require you to use network block storage or NFS, which is slightly painful to set up, or GlusterSF. So you essentially have to spend some money on cloud provider storage that you mount over a network that pets use, or you have to set up something more complicated like Gluster. And this essentially means that there are two classes of applications that could benefit from a different type of storage that is not these two. First, you have the really high-end applications that want low latency access to SSDs and don't want to go over a network. And then you have the really low end app, or not the low end, but the dev and test prototype type things that you don't necessarily, you're going to be quickly tearing down your cluster because you're iterating on design and you don't want to spend money and you don't want to, set up a Ceph cluster. And both these would fit well with what we've till now described as data gravity. And it's the design. I put up a design doc like literally yesterday. If you guys want to look at it, just go for, PRs created by people.
I didn't catch that. It was data what?
Data gravity.
Data gravity. Okay.
Yes. It's the ability to attach sort of local storage to persistent volumes and have pods use that across restart such that they always get scheduled to the node.
Is there a design doc on that?
Yes, it's a proposal. It's not a doc. The proposal, I don't remember the number. I put it up last night. You can find it if you look at proposals by Prashant. Well, proposals assigned to Tim Hawken would be probably easier but a larger list. And it's essentially about local storage. And I think it would enable the two use cases I mentioned. There are other ways we could tackle the storage problem. Like, I think I spoke to Clayton about getting the Gluster setup streamlined into Kubernetes, because today it's a little harder than it should be to set up either Ceph or Gluster. Or honestly, I haven't tried Torus, but I probably should. And that's another viable option, right? That solves one of the two problems. The problem is sort of twofold. One is local storage. The other is network storage. You could expose local storage over a network, and that potentially wouldn't solve the latency problem. But it would solve the local storage problem. And I think there are things like Hakeri that allow you to expose Gluster as a sort of RESTful interface that essentially tells you where to put the bricks. When I read about it, it was essentially like the GFS master. I'm yet to prototype something that works with vanilla Kubernetes, but that's another way we could solve the storage problem. I guess the exit criteria for the storage problem is it should be easy to use without necessarily spending money and really simple to set up without another major failure point. Like if we did set up Gluster and it just happened to flake, which maybe it will or will not, I've heard different mixed reports, then that would not provide us to exit this criteria, right? Having discussed storage, the next bucket is just difficult distributed system edge cases. And this is something that we've been going back and forth on, and it's really hard to draw a line about where exactly the boundary of what PetSet should do and shouldn't do lies. There are certain patterns that we see people trying to solve repeatedly by themselves with Kubernetes. And I think we should try and make it easier by distilling some of these patterns into the system. This is a little more challenging than it sounds because it requires a lot of prototyping and it requires fleshing out of these patterns. This is kind of, I guess, where I need a lot of the community help, because I've been prototyping a lot and some of these prototypes make sense to me because I'm very familiar with PetSet because I developed it, and I am pretty familiar with the rest of Kubernetes. And so it's not that hard for me to write error-free PetSets or init containers. But even so, I found that other people, even some people I work with, I ask them to write an init container and they might have made some mistakes, or there are just things that they didn't think of at first blush that were pretty obvious down the road, and maybe there were some documentation issues there. But by and large, I think I just need people who are not me or Clayton or someone who is very familiar with the design to try and prototype their database of choice. If you were interested in doing this, you would look up all the GitHub issues labeled state apps //stateful. And there are already a bunch of issues files saying support database X on PetSet. Some of them have been fixed and some of them haven't. If you're interested in an existing issue that's filed there and you want to try it out, I would suggest just commenting on the issue saying, hey, is anyone working on this? If not, I'm going to grab it, prototype it, come and ask me for questions, and we can take it from there. What I'm really looking for is, I tried doing this with what we have today, and I needed to write a bunch of code to solve this condition, right? Perhaps I needed to write like something that watches the Kubernetes API and proactively take some action or something like that. I don't know what it is. But essentially, if you could come up with that feedback, we could distill that back up into the system. So that's the distributed systems sort of bucket. And the final bucket is essentially we need to support frameworks that use databases such as Kafka and Spark. And this is going to be an additional challenge because whenever we've tried to layer a system on top of another system that we're developing, like edge conditions and bugs happen. This happened with replication controller, for example, and deployments. Replication controllers were really stable, or at least so we thought, until deployments tickled them in all sorts of weird ways, and then we found all sorts of issues, right? So I'm assuming that when someone tries to use PetSet and Zookeeper with Kafka, we're going to run into both edge conditions and sort of failings of the design that need to be improved. So that's another area where anyone familiar with any of these frameworks could help prototype. Yeah, but that's pretty much all I have.
So this work is happening in and around SIG apps as well. So if people want to discuss it, would that be the place to?
I guess, yes.
On top of
yes,
all of the pull requests and issues and such.
Just be sure to notify me if you want me to show up somewhere, because I have a tendency to just get lost in my Vim console and keep coding away. So I'm Beeps on Slack. You can like ping me there, or just send me an email or something. But yeah, SIG apps would probably be a good place.
SIG apps.
Can you give us?
What were you say, Bob? I think we were going to probably ask the same thing.
So we've been doing a lot of work with PetSets with two database systems that you haven't mentioned, with both Postgres and with Scylla. The Scylla is kind of a follow-up to a bunch of the Cassandra work that we're doing. I don't think we necessarily have feedback, at least not yet, on, well, like feature X is broken and we need something else. But I do think we would like to see those databases, and I assume others, added into the ETE, and we want to be able to share our work. So every time this share work and someone asks a question about contrib, Brian will say something like, "Contrib is dead."
So the E2Es are not actually in contrib right now. The E2Es are using images that are in Kubernetes / I think test images or something. You should be able to open up the test E2E PetSet file and figure out where they're using the images from. I mean, the sort of documentation stuff is in contrib, yes, but the actual YAML files that are a part of the E2E are not in contrib. So,
give us guidance on how to, what's the right way for us to share our work into the community for the Scylla and Postgres work we've been doing with PetSets.
Okay, I'm going to defer to, does Brian have any options? Because I want to say contrib, but I know he's not going to like it.
Hey, look, here comes Brian.
No, create a new repo.
Okay,
Well,
yeah, but they want to get the E2Es. So I guess create a repo with the examples and then check in the YAML to somewhere where the E2E can access it and it'll run.
Yes.
Hey Bob,
Yes.
sorry, can I just ask a question? Are you looking for EDEs on nightly builds?
Today it runs back to back like every 20 minutes. It uses head.
Right. I wanted to understand what Bob was looking for. Sorry.
It's part of a discussion. I want to make sure that if we're doing regression in some respects across a set of databases, that we have a good, clean community way to extend that set, so we're able to catch as many problems around as many different systems as possible.
Yep.
If you want to get this tested continuously, like we have E2E tests, they're in the main repository. You should contribute there.
Yep. I think it's sort of open to how we would test this in a distributed fashion so that everyone can use it. But like Daniel said, there are E2E tests that are pretty much running it from head today.
The only reason why you wouldn't do that is if you have some sort of like bare metal cluster setup component that you want to test. Like you can't test that with our system. You'd have to federate testing in some way. But if you just want to test config that runs on top of a Kubernetes cluster, that's the place to do it.
I see. I'd actually be interested in tossing out potentially a crazy idea here, and shout me down if I'm being foolish. What if we actually checked in your work into the charts repository for Helm, and actually made this a first class, easy to install application there? I'm not clear what end-to-end testing is done there, particularly against head. Certainly we should investigate it, but the fact that you guys, you folks are out building these amazing applications, we know people want Postgres, we know people want whatever the other database you mentioned was, like those are things that absolutely people want, and the community is coalescing around Helm as the way to easily install that. I'd like to toss that out. Does that make sense?
So I want to raise one point of concern is we're still in the point of all of these are going to be, you have a non-zero chance of this eating all your data and going back to start. So I am at least somewhat concerned about anything with PetSets or anything that we've created on PetSets being advocated to end users in any way until we're comfortable with them, which is 6 months down the road.
Yeah, and actually, with the features being alpha, they're not going to work in all clusters.
That's true.
And there aren't tests against that repo currently, so that's work that still needs to be done. So I don't think I think we want that, but we're not ready.
Yeah, I want to advocate for people having easy ways to get at these, but I do not want someone confusing these for anything that should come anywhere close to production yet.
Yeah, we have a soak test that runs a cluster for a week. Like we should, for things like this, we should really have tests that start one up at the beginning of the run and like verify that it at least survives the week. That's not sufficient, but it is at least some low-hanging fruit.
Yeah, unfortunately, so far, I mean, most of our tests, or maybe all of our tests, I mean, they don't actually test that the applications really work. So that's new ground that we need to cover.
Yeah, no offense to Prashant or anybody else who's worked on a PetSet so far. Like there is a very big gap between we've made these work and the stuff we've done, and this is a supported configuration. Like, and I think that's the challenge is we need soak time on PetSets, and we want to ensure that as many people and as much infrastructure is brought to bear to soak it, but we also need people like Postgres authors, like people who are committers to Postgres going, yeah, I can follow this, and like deep reviews on the consistency of these systems, right? Like, these kinds of things are the things that Jepsen tests are designed to go flush out, right, and prove that we actually didn't do anything correctly. We haven't even begun to start that work too.
Yeah. So this sounds like lots of work to be done in SIG apps.
To be clear, to just answer Joe's question, I wasn't implying that the end-to-end tests would enforce Helm usage. It was more within the Helm. Within the Helm repo, they would build their own tests and do nightly or whatever made sense for them end-to-end testing. They would be decoupled though. So okay, and I'll be quiet so Eric can speak.
Eric, yes.
So we're talking about PetSet and we're talking about Helm. They're related, but make sure they're clear. They're different in our minds. I see PetSet as a thing that helps you make a pre-container app run well on Kubernetes. Bob mentioned projects that are next generation, like ScyllaDB, which is next generation of Cassandra, and MariaDB, which is next generation of MySQL. It'd be great. Actually, Bob didn't mention MariaDB, but someone did. It'd be great if we reach out to those applications and make sure they're cloud native so they don't need PetSet. It's always preferable to use a deployment and services and have the thing be Kubernetes native and scale fast than to use a PetSet. PetSet is an adapter. It's not an end goal for applications on Kubernetes. And then in terms of like testing end-to-end, great point by Brian about wanting end-to-end testing. One thing I'd like to see is for Helm charts and we talked about this in a recent meeting, when they install the server, also say, here's how to configure a client. And even maybe to have like a little minimal ping from that client. So then we can have an E2E test, which is not a Kubernetes core E2E test, but it's more like a Helm E2E test, which says install a thing on a recent release Kubernetes cluster and have the client for that server, like MySQL client, Redis CLI, ping it and make sure it's up. That's all.
Okay. Yes, and Joe brings up a good point. We have a lot of other things to cover. So more discussions about PetSet, more discussions about running long-running applications on Kubernetes in SIG apps.
I'm going to interrupt for 1 second and just make a pitch. Please come to the SIG apps meeting on Thursdays.
Woohoo.
To help.
Is it on Thursday?
I think it's on Wednesdays, isn't it?
Today, basically.
Oh, there was one. There was one at 9 a.m. I don't know if it moved. Anyhow, sorry. Moving on.
Okay, it's listed and it's on Wednesday mornings, 9 a.m. Okay, so Daniel, do you happen to be at your desk and have video?
I am at my desk, but I don't have video on my desktop.
Okay. Well, then
I can come to your room.
well, you could come over here. Why don't you do that actually, and we'll do. And can you bring the?
Yes.
Thank you.
What room are you in?
I'm in 90 Mile Beach.
Okay, I'll be right there.
Thank you. All right, so let's go on to our SIG updates. We will do up next. Holy cow! Thank you for all the notes, Joe. SIG cluster lifecycle. Luke, you are up.
Hello. Hey everyone, how's it going? I am just showing my screen.
And we can see it.
Awesome. Okay, cool. So I'm just going to give a short, hopefully less than 10 minutes update on what's going on in SIG cluster lifecycle. The primary goal of SIG cluster lifecycle is to make Kubernetes itself really easy to install for 90% of users. We're assuming those users are going to want to kick the tires or go into production. I've divided the following user stories. So in the next few slides, there are going to be a few user stories that we're targeting. I've divided them up into phase 1 and phase 2. Broadly speaking, phase 1 is stuff that we hope we might achieve in time for 1.4. Phase 2 is longer term stuff for these user experiences that are going to be more production ready in time for 1.5. And so to be clear, we're only targeting an alpha release of what follows in time for 1.4. Just before I go into those user stories, I just want to make something clear. Sorry about all the words on these slides. I wanted to make them self-explanatory for people who look at them later. But just to summarize, there are really 3 stages of bootstrapping. There's provisioning, discovery, and then add-ons. And I just wanted to clarify that what we're focusing on in SIG cluster lifecycle is only 2 and 3. So what that means is we're not shipping something which is going to automatically provision instances on AWS or GCE or any other, or Azure or any other cloud providers. We're just focusing on the user experience that users get when they kick the tires with Kubernetes by typing commands into the root shell of some servers. The reason for that is that there's many different ways of provisioning servers, and we didn't want to get into the game of being opinionated about that. And we know that users will have their own preferences, but once we've made 2 and 3, bootstrapping, discovery, and then add-ons much, much easier, it will make the job of tools that want to do the provisioning as well much easier. It'll also become sort of self-evident to users who want to automate it with their own choice of Chef or Puppet or whatever, much easier once they can see the new easy way of installing Kubernetes. So I'm just going to blast through these different user stories. The main, almost the most important one is the initial installation experience. So as a potential Kubernetes user, I can install 1.4 on a handful of computers by typing 2 commands into each of those computers. And the process, as I said, is simple and so obvious that I can easily automate it. So that's the phase 1 target. So we're going to try and get that into 1.4. Also in phase 1, we want to get a basic pre-flight check in. So if any of the computers that you're trying to install Kubernetes on have like a bad version of Docker or a too old Linux kernel, then bail early so that I can like figure out, oh, maybe I need to put a newer version of Ubuntu on these machines or something. The next one is control. So obviously, once you've provisioned a cluster, you actually need to get some credentials that allow you to control it with kubectl. And also as part of phase 1, being able to install cluster add-ons using kubectl apply. And that includes networking add-ons. So in parallel, we're working on making sure that, for example, WeaveNet can be deployed as an add-on just using kubectl apply. A couple more user stories. Being able to add a node is actually kind of easy if you can satisfy the installation story, because if you've added a computer to the cluster early on, you can add a computer to the cluster later. Upgrades, we are currently thinking about punting on, because we're going to be labeling this feature alpha and we need to get the software written in the next 2 weeks. We are going to punt upgrades out to out to probably 1.5. Final user stories and requirements. We want the system to be secure so that if an attacker is controlling the network, they can't add malicious nodes and can't remotely control the cluster. And HA, so that's phase 1. HA, we are punting out to phase 2. So if one of the computers fails, the cluster carries on working. That's basically multi-master. And that's going to be a little bit too complex to land in the next 2 weeks. So on to the good stuff. This is what the user experience that we're proposing actually looks like. So these are the 2 commands that the user would have to type. The first one, the first thing to point out is just what's in the orange cloud in the top right here. So one of the assumptions here is that the user has installed Kubernetes from an operating system package. And what that means is that things like, it allows us to sort of smooth over the problems of needing to install systemd unit files, for example, or upstart scripts on operating systems that don't have systemd unit files, because that can all just be hidden away in the operating system specific or the disk specific. So we're assuming that the user has already typed something like apt-get install Kubernetes, and Mike Denise is working on packaging for devs and RPMs. So this is going to be possible. So this is the simplest example of installing a Kubernetes cluster. The user types kube init master on one machine, and they're given a secret token back. And then out of band, they maybe copy and paste that token over SSH and paste it into kube join node on however many machines they want to add as nodes. And so that token acts as a secret, which allows the nodes to form a secure network, and you pass the address of the first machine in so that the first node can find the second node. And the consequence of that is that the user gets a single master cluster with n nodes. The slightly more advanced sort of phase 2 would be if you want to, so we're sort of thinking about how the UX will look for the HA master scenario. That would be kube join with the same token with master on some of the nodes. And one thing that's worth pointing out here is that even though you type init on one machine, as soon as the control plane is established, that one machine isn't special anymore. So in the multi-master case, you wouldn't end up with a single point of failure. Just one note on discovery. In order to implement this user experience that we all want, we are currently exploring a secure gossip-based solution for bootstrapping versus a public discovery service. This is still in sort of an exploration mode. We're trying to figure out whether this is possible. We think it is. We want to prove it with a prototype. And the reason for that is that, as David said in the last SIG, users don't want to leave their firewall where possible, and users don't want to run and operate incremental services. So Ilya and I and Mike Denise are working on a proposal for this discovery that we're going to share as soon as it's looking sensible. So everything else that I've talked about is a work in progress. Please come and get involved on SIG Cluster Lifecycle on the Slack. There's some links in this presentation. The presentation is linked to from the minutes, and that's it. Any questions?
I'm gonna say, since we're tight on time, that questions should go to the SIG Cluster Lifecycle Slack channel or to the meeting next Tuesday at 9 a.m.
Awesome, thank you.
Yeah, apologies for cutting you short on that, but we are tight on time. And I am going to now interrupt our regularly scheduled programming for a 1-minute announcement in our retrospective of 1.3, there was a particular name that came up over and over, and people have commented across the community about the extraordinary work done by Daniel Smith in 1.3 to keep us moving forward and get us through and out to 1.3. So I took it upon myself to make the first Kubernetes Community Award, and present it from the 1.3 release cycle to Daniel Smith for being the nut that held it all together. And this, for those of you who can't see it, is actually a 7-sided lug nut that we went out and found in bright blue, of course. And so this goes to Daniel with our thanks collectively. And so there's Daniel. Yay!
Thank you.
You found a blue 7-sided lug nut.
Much appreciated. So
You are most welcome, Daniel. A blue 7-sided lug nut. Yes, John. Or sorry, yes, Joe. So that was actually the brainchild of Eric Toon, who happened to find it, because why wouldn't you have a Google search set up for heptagon? So thank you, Daniel, for joining us, and thank you for all the work in 1.3.
yeah, thank you. I didn't need this, but
But it's yours. All right, so now we can return to our regularly scheduled programming and move on to SIG scheduling. Tim, I saw you put a whole pile of notes in. We've got 7 minutes and at least a notice from Ihor about 1.4 features. So let's go.
I will keep this short and sweet. We have not met in the SIG scheduling group for several weeks now. So we recently had a couple of items that were kind of fairly high priority, so we decided to meet, and we also are going to have some upcoming events soon too as well that we wanted to give a PSA for. One of the agenda items we talked about this week was regarding Intel's proposal on binary counted resources. There's a link in the notes there. This crosses several SIGs, so you're going to see aspects of this cross from SIG node as well into SIG scheduling. The primary topic that we were covering was how we were going to do the matching on what data. We kind of resolved that there would probably be an annotation on the node resource information, and there was still debate upon whether or not we were going to put the resource requests into the pod spec or yet another annotation on the spec. So that was still a TBD item. The next agenda item that we've recently been talking about was what was it going to land for 1.4 cycle. The biggest thing that's landing in 1.4 is going to be the pod and node affinity and anti-affinity, and they should be enabled by default now. So there have been some performance modifications that Wojtek has made, and for those who are interested, feedback is welcome. So try it out, see how it works, give any tidbits or advice on your experience would be useful. There's still debate whether or not this should be moved from an alpha to a beta feature. That's still open for debate, so that will likely evolve over the course of this cycle. The last thing that we wanted to call out was we wanted to give a PSA for a larger audience that next week during our SIG scheduling meeting, we're going to, the CoreOS folks have gladly offered to show a demo of one of their interns who had rewritten Firmament, which is a flow-based scheduling algorithm in Go atop of Kubernetes. So for those who are interested, it should be a cool demo.
And that's in the next SIG scheduling meeting, you said?
Yep, Monday at 2 Pacific.
Monday, 2 Pacific. Thank you. See, we have to get that public service announcement out there too. Every time we say SIG, we say time. Yeah. Or Slack channel. Awesome. Thank you for the info. Do you know if SIG scheduling is going to try to be more consistent about meeting, or is this going to be ad hoc still and managed by the mailing list and Slack channel?
I think it'll probably be ad hoc for a while as topics come up.
Okay.
Just to be clear, the meeting time is and day is standardized. It's just we've been canceling them when there wasn't any agenda items. But we would love to have more meetings and have more people bring up topics so that we can justify having more meetings.
I'm sorry, David, did you just say you would love to have more meetings?
I meant that figuratively.
Okay.
We would love to have more community feedback.
That's what I meant.
There we go. More community engagement, which might lead to more consistent meetings. Okay. Fantastic. Awesome. Thank you both for leading SIG scheduling and updating us on all of this. And I'm going to do the same thing with questions. I'm going to send you off to the SIG scheduling mailing list and SIG scheduling Slack channel if you have questions for Tim and David. Ihor, do you have a 3-minute variant of updates on 1.4 features, and maybe we can do a deeper dive next week if there's warrant?
Well, right now I have 2 minutes updates, so we'll have like in the schedule. Let me share my screen. Yeah, so do you see my screen?
Mm-hmm.
I suppose you can. So I have collected all the items that were submitted to the Kubernetes features repo and marked as 104 milestone of this single spreadsheet that is like an Alex like spreadsheet that we have prepared with Mike Zapara for 1.3 release. And this spreadsheet is much more implemented and I suppose it will be much more informative. So I'm going to track all the features that are expected to be added for 1.4 release of Kubernetes, and I'm going to track them from the features repo. That doesn't mean that all these features, there are 37 features, that doesn't mean that all these features will be added to the actual release, but it means that these features are expected to be added one day, and in 1.4 release scope, the people are working on them. At the same time, I'd like to ask people who are owning the features, please update them with the actual data if you have some updates, because there are a lot of like features issues that have been not updated for a long time, but they're still actual, I suppose. And also, I may remind you that we are expecting to close the coding stage for 1.4 in 2 weeks. So if you are actively coding some stuff for Kubernetes and expected this stuff to be included to the actual release, please finalize that in the nearest time in 2 weeks. Yeah, that's all from my side.
Excellent. Thank you, Ihor. And if people want a broader overview of the features that are being worked that are not bubbling up through SIGs, if there are specific features that you haven't heard about, please reach out to me and let me know. We have 2 whole minutes. Any notices, anything anybody else wants to mention?
So as real quick, as we look towards 1.4, this came up in the scale meeting this morning. Are we going to like have 1.4 gigabytes for the download, and maybe 1.5 will be 1.5? I know like there's an issue on this. I think everybody knows it's a problem. It seems to be falling through the cracks. Is anybody actively working on it? I don't think so, but I just wanted to.
Didn't you pick that up, Joe?
I filed the issue and then I went on vacation for 2.5 weeks, which is what architect and high-level engineers do, right?
Yeah, I'm going to blame PEDCAC in this case.
What's that?
PEDCAC. Problem exists between chair and keyboard. That's all you, buddy.
That's probably what's going on. But I'm just wondering if anybody
we're
running down the clock there, and it would be nice to not have a 1 point whatever gigabyte download.
I think it's a generally well understood thing, but I'm sorry to report that no one that I know of is working on it. It is trivial like a trivial exercise to get it down like of its current size.
All right, David, you take it on. I hear you signed up. You called it.
Yeah. Here's what will be the death of this project, me checking in code.
Who actually owns the release infrastructure and the whole process of cutting a build and how it's structured?
That's David McMahon. He would love to have help if people are interested. There is a roadmap document with a ton of stuff that needs to get done, a ton of stuff. There haven't been enough people interested to create any kind of SIG or anything. So, but if more people are willing and able to dedicate time to help, then we could at least create a working group or something to facilitate collaboration. But for the moment, just reach out to David McMahon. And
was the question about the release tarballs being too big? Was that?
Yeah.
He commented a couple of weeks ago on it. The issue is 28435, and he said he was not going to have bandwidth to do it by the 1.4 deadline.
I thought I saw a change that like removed part of things, but it broke the testing and was reverted. So
So there's
so
opportunity for people to help.
yeah.
Anyway, yeah, I think if you have comments, the issue number is 28435, and that's probably the place to go.
But so just to be clear, it sounds like there's no actual SIG or working group that owns this, just to restate what I heard Brian say.
Just one person right now. So
David, would you mind having him send out to Kubernetes Dev that sheet? Did I say David? Brian?
Yeah.
What?
Just ask him real quick.
We can also figure out if there is a need for some sort of structure around that or not, or if right now that becomes part of one of the other SIGs. We can look through the list and see where it might fit.
I may remind you that we have Kubernetes PM group where we have initially started discussing all that stuff. So possibly it might be a best place to collaborate with all that stuff.
Yep. Awesome. And we are 1 minute over, so my apologies. Have a lovely week, and we will continue this next time. Send me ideas and suggestions for topics, because this is the first time we are out of runway for demos. So if you know someone who wants to do a demo, it's next week. See you guys soon.
Thanks.
Thanks.
Bye.